So here's some more examples of applying transformations without, instead of using parent function, we'll just use some generic graph. This will also help remind us of the function notation idea. So notice what we're saying here is that f of x, the function I'm dealing with, or in a sense the parent function is this little graph right here. So then we're going to do the following transformations to each one of, to the same graph, and see what they look like. Okay. So if you understand function notation, this means that I'm adding 1 on the inside and subtracting 2 on the outside. So if we go back to that grid, that means that we're going to shift left 1 and down 2. The shift left 1 comes from that, and the shift down 2 comes from that. Okay? So we're going to take this graph over here, the original graph, and do those two transformations to it. Now, instead of, in a parent function, we kind of know the whole graph shape of the graph, so the way we do that is different. In this case, because I don't really know the shape of the graph that well, it's a finite graph. So what I would do in this case is just apply the transformation to a couple of key points. So for example, this is a key point right here where it hits the x-axis. So if I was to shift that to the left 1 and down 2, so if I go over here, we're going to start at the point -3, 0, and I'm going to go to the left 1 and down 2, and I end up right down there. So that yellow spot ended up coming right there. Then I'll do the same thing with another key spot, like, for example, the little peak up here. So if I wanted to transfer that thing, right now it's sitting at 0, 3, so it would have to go to the left 1 and down 2, and it ended up right there. So that's the result. Now, all we have to do is connect the dots. And so what we're saying is that this little string here ended up going right there. And then if we do that to the next one, I'm going to not necessarily color all these, but if you take the point right here that's over 2, up 1, move it to the left and down 2, that would end up right there, and I could connect those. And then finally this one up here that's way up here, it's over 1, 2, 3, 4, 5, 6, 7, and up 1, 2, 3, 4, 5, 6. So that means it's going to go over 1, which makes it, and down 2. Wait, sorry, I lost track there. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and up 1, 2, 3, 4, 5, 6. So I'm going to go back 1 and down 2. And I end up with that. So you can see that this new graph looks just like that one, same shape, but it's been moved to the left 1 and down 2. And that is the idea. Okay. Moving on to the second one. So this one says I'm multiplying by 2 on the inside, which is going to produce a horizontal stretch by 1/2. Because remember, on the inside, the stretching has a reciprocal effect. So that means every point is going to be half as far away from the y-axis. Okay, so right now, again, if we go through that same logic, the yellow point, which you can hardly see the yellow anymore because the blue overlapped it, but the yellow point is at -3, 0. So if I make it half as far away from the y-axis, that means it's going to be at on negative 1.50. So I end up right there. This point up here, the green one, is on the y-axis. So if it's half as far from the y-axis, it's still going to be on the y-axis. So that'd be in the same spot. That doesn't move. And then if we connect those two dots, we get something like that. This point down here, just so we can follow, I'll make it, do we have another pin color here? How about pink? Pink's fun. That spot is pink. Where's it going to go? Well, it's 2 away from the y-axis, so now it'll be 1 away from the y-axis. But notice the y doesn't change. Whoops, I missed. There. Stop. My pen is having trouble hitting the right spot. There we go. Now if we draw that, there we go. So you can see it's producing the effect of getting scrunched up. And remember, this point up here was 6 away, so now it's going to be 3 away. I'm sorry, 7 away, so now it's going to be 3.5 away. So I'm going to go up 1, 2, 3, 4, 5, 6, and over 1, 2, 3.5. So it'll be right about there. I'll just draw a line right to there. Okay? We go to the next one here, the third one. This has got a 2 on the outside, which means it's a vertical stretch by a factor of 2, because on the outside it stretches the factor in the equation and the stretch factor are going to be exactly the same. And so, and again, since it's a vertical stretch, we're stretching away from the x-axis. So the point that's on the x-axis is going to stay right where it's at. Oops, right there. The point that's 3 up on the y-axis is going to go to 1, 2, 3, go up to 6. And then if we draw that, you can see it produces a stretched out line. The point that was 1 above is now going to be 2 above, but the x value doesn't change. So that produces that. And the point that was 7 above is going to go off the charts, isn't it? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's going to be up there somewhere. And you can see that once again, this thing looks like that, only it's been stretched out, and it's a little bit, the look is a little bit distorted too, because this one point over here, the yellow point, was anchored to the x-axis, and so it got stretched and distorted a little bit. Okay. Now, when we get down here, we're going to do the same thing, but I'm going to be a little bit more detailed because now we've got a lot of stuff going on. We have a reflection. Oops. Yeah, we have a reflection. We have a vertical stretch. And we have a shift left. Okay? So, one way to do this is to take a point like negative 3, 0. And I'm going to go, oops, negative 3, 0. And we're going to apply each one of the transformations to it separately. So, after the reflection, and that is a reflection across the x-axis, that would just change the x-coordinate. I'm sorry, it would just change the y-coordinate. Of course, it's 0, so it's not going to change. So after the reflection, it'll still be negative 3, 0. Then if I apply the vertical stretch, that means I'm going to multiply the y-coordinate by 2. And of course, the y-coordinate is 0, so it's still going to be negative 3, 0. And then finally, I'm going to apply this shift to the left one, which means the x value is going to be 1 less. So I end up with the point negative 4, 0. So that yellow point ended up going 1, 2, 3, 4. Now that one wasn't very interesting because 2 out of the 3 transformations didn't produce any change. So let's look at another point like 3, 0. I'm sorry, 0, 3. X coordinate 0, Y coordinate 3. So that'd be 0, 3. And we'll do the same thing. So if I apply the reflection across the x-axis, this becomes 0, negative 3. It just flips down, right? And if we apply the vertical stretch, that's 2 times the y-coordinate. That's going to be 0, negative 6. And then finally, if we move it to the left one, that's going to affect only the x-coordinate. That'd be negative 1, negative 6. So I end up at negative 1, 1, 2, 3, 4, 5, 6. And I need to draw a line there. Okay, so I continued on in that fashion while the video was off and did the same thing to the other 3 points. The other 2 points, and you see that I end up with this point right here and this point down here. It's off the charts, actually. I ran out of room down there. So again, doing that same process where I applied the 3 transformations to the point negative or 2, 1 and the point 7, 6. And so anyway, that's and we can do the same thing on this one here. The last one, again, I would take the time to pick the points and apply all the transformation to it. In this case, you're going to have a vertical, a vertical reflection because of the negative, a vertical stretch because of the 2, a shift left because of the 1, and a shift down because of that 1. And you apply those 4 transformations to each one of those points, and you should come up with a good graph. I will post the solution sheet on the on Canvas, and so you can try your hand at that last one and then go to the Canvas sheet and look at it, make sure you did it right. All right.